Hi, my name is Rob McLeod. I'm a professor in the Biomedical Engineering Department at the University of Utah. And my job today is to explain to you a little bit about what I think, what I've learned about what makes a great engineer, and eventually what makes for great engineering studies and even a career in engineering. And there's lots to say about it, but I wanted to give you at least the high points of what I think are the key ideas. Now, who am I? When I'm not out riding my bike or skiing or spending time in the mountains, otherwise in our amazing state of Utah, I'm a professor, which means I get up in front of classrooms, I give lectures, I talk to people, I give talks. I'm a researcher as well, which means some of those talks are at conferences, and I get together with groups of other colleagues and students and pursue topics, in my case, in biomedical engineering, to try and improve the lives of people through research and through new developments in engineering, and try and enable research in other topics through the engineering that I can help develop. So I'm an academic engineer, and not many of you will likely end up being academic engineers. It's much more likely that you'll end up working in a company. You'll be an industrial engineer or an engineer in industry. And so I tried to find suggestions and comments that I think are applicable to any type of engineer, whether it's an academic or eventually one who works in industry. And so what do we do first when we have a new problem to solve in engineering? Well, we do research. And so I went out and did the research, and I found lots of interesting material. And this is always what we find when we start a project. We do some research, we do some digging, we do some searching. We go to the past. We look at past, say, scientific articles if it's relevant, to textbooks if they're relevant, or just go out on the internet and search and see what we find there. And I did that today. And so I want to share with you some of the comments and suggestions that I found in my research that I think also reflect what I found in my own career as an instructor, as an engineer of many years now. So the first thing that I learned when I went looking, and I completely agree with this statement, is that there's no such thing as a stupid question. Engineering is challenging. The materials you will have to learn in engineering in your education are very challenging. And there's times when you'll be confused in a classroom, sitting in front of your homework assignment, trying to read your textbook. And there's really no such thing as a stupid question if you've thought about it, at least to the extent that you can with the materials you have at hand. So feel free to ask it. Ask it in the classroom, because chances are there'll be other people in that classroom who have the same question and will appreciate somebody having the courage to actually ask it. If you have other questions, reach out to your fellow students, reach out to your professors, the TAs, the people helping with the course, and ask them the question. Because if you don't get it resolved, if you don't get it answered, you're going to get stuck. You're not going to be able to move on to more advanced topics. You're probably not even going to be able to do the homework properly. So don't hesitate to get answers to your questions, even if it takes a little bit of time and maybe exposes you a little bit to potential embarrassment. It's worth it for the benefits you get. Now, a related thing to having people to ask questions of is that the students around you as you come into engineering are forming the basis of your network, your professional network. This is the network of people who can help you throughout your studies and potentially even throughout your career. I have colleagues I met in university who I still occasionally have contact with at international meetings or in very unpredictable settings. And I certainly have a network I've built up after 30 years of teaching and working here at the University of Utah that I depend upon for all sorts of assistance and for the opportunities to pursue really interesting projects. So build that network, get to know people, get to understand them, try and just recognize what it takes to form relationships that are professional relationships with people. Now, related to that is, even when things don't go well, even if you discover this is not maybe a person you want to work with closely in your study group, or it was a lab partner choice that hasn't worked out so well, don't burn bridges when those relationships split up. Be nice, don't be a jerk, be respectful. Understand that there are just differences in styles and different ways of working together, and that they're all okay. Find the people you really like to work with, but don't get a reputation as somebody who's difficult or that leaves a relationship in flames, rather than finding smooth ways to disentangle themselves from relationships and network agreements that maybe don't work out. Related to the very first topic of there being no dumb question is learn how to ask for help. It's okay to need help. Nobody expects you to come into university or into a career and solve all the problems on your own. That's ridiculous. You can get passive help by looking at your textbooks and looking at materials and doing your own research, but feel free to reach out to your peers, your networking partners, your study group, also your professors, the people around you. Most departments have fantastic advising teams who are really there to help you with really everything that comes up, not just the academic questions and the technical questions, but also the emotional questions, sometimes even the financial questions. So realize that you truly are not alone. You're part of a community at this university, and we really are here to help you in virtually any way we can. A point that comes up a lot in education, and I certainly hear this comment in my classes, is why am I learning this? How is this going to help me? This obscure equation, this obscure technique, this particular computational skill or computer program I'm supposed to learn. All I can tell you is it's really hard to predict what you'll eventually need in your careers. I certainly would be the first to admit that I had to learn things as a student that I've never used in my career as a researcher or as a professor. But I didn't know at the time which those were, because there were many, many things I did learn then that I still use almost every day in my career. So the point is that because you can't decide, and because they're arguably valuable to somebody, it's worth learning them. So don't agonize too much about the relevance of what you're learning. Just learn it and realize it will have potentially some purpose in something you do later in your career in ways you may not be able to anticipate now. Of course, it's always fair to ask the professor where this particular detail fits into the bigger picture. When you're in the course on physiology, why should this concept of electricity matter? There's a connection, and a professor should be able to make that connection for you so you see the context in which what you're learning leads you into deeper areas of that material. But have a little confidence and have a little patience and just learn it. Your brain can handle it. So just learn it, and some of it will come back in very positive ways later in your life. Related to this too is this notion that you're going to have to find a way to push yourself pretty hard. Engineering is not an easy subject. University generically is not easy. It will have its challenges, and you can deal with those challenges with the network, with the help, with the ability to ask questions. But there's a certain part that's you. You have to create that motivation, create that drive that's going to carry you through the hard times, which are inevitable. Every course, if it's a good course, I would argue, has some hard phases, some challenging parts. You have to push yourself to get through and learn how to motivate yourself to get through those hard parts. Related to that, and related to the other point about deciding what's worth learning, don't limit your skills to just the obvious engineering skills, the obvious ones that are related to your field of chemical engineering or mechanical engineering. Realize that there are other skills you'll need to develop. You'll need to write documents and produce figures for those documents. So take the time to learn some of the technical skills to create great documents where you control the layout and you control the look of that document, and in which you can incorporate really well-crafted figures and graphs and all those things that make up a good means of communication with other people. Learn how to use a program to make slides, to make a presentation that you're going to be giving, because at some point you'll have to do that in your career or even in your studies. So follow your curiosity and learn to become something of an expert in a number of these sort of ancillary or somewhat peripheral technical topics especially, and they'll be very handy for you later on. And speaking of getting experience that's practical, get hands-on experience whenever you can. Try and get out of the mode of thinking that everything you learn is going to come from a book or from something you read, and realize that there's a very valuable skill in learning how to do things, and you only learn how to do things arguably by doing them. The theory of building something is quite different from actually building it. So take whatever opportunities come along to dive into things and actually do them, whether it's in a lab that's part of a course, whether it's an internship that you might do with a company during a summer or even while you're still in school. It could be an experience you have with a faculty or with a research team that allows you to get into the lab and actually do real research. You will always learn enormous amounts by this hands-on practical experience, so take advantage of it. Often in these settings, you'll be asked to work in a team, and that's another very valuable skill set to create. Along with this networking skill and this ability to interact well with others, recognize that teams are very important entities. Engineering functions in teams, whether it's industrial engineering or academic or research engineering. So you have to be able to interact with each other, recognize strengths and weaknesses, be patient with each other, generate excitement together, do things that build the camaraderie of that team. And you'll be much happier and much more successful, in your career. One of the things that students often don't follow is their emotional response, their recognition of certain areas, certain topics, certain applications that just feel right. And that takes a little bit of time and a little bit of what I call reflection. So take the time to reflect on the courses you're in, on the activities you're pursuing, and try and identify those that seem to fit with your skills, that fit with your idea of what's interesting. And those are the ones you probably want to steer toward, because you'll have many decisions to make along through your studies and certainly in your career. And they can be challenging decisions, and they sometimes are practical ones, but more often than not, they really should be driven by what you like to do, what you're good at doing. And oftentimes it takes some thought and some reflection to identify what those are, similarly to identify those ones that maybe are not really your thing, and act on those feelings. And as you're looking around and going through your schools, or going through your studies, feel free to look outside that field that you started in. Look at neighboring domains of engineering and make sure you know something about those. Most projects cross over domains. A robotic arm involves mechanics and electricity, and it may even be connected to a human, so it involves physiology and biomedical engineering. There are all sorts of aspects that make up really interesting projects. So be open to those neighboring ideas and disciplines that may not seem to fit right away with your chosen field of study. And finally, don't get lazy over the summer. So the summer is a great time to kick back, to relax, to recuperate, recover. And those are all important activities as well. But you can also use the summers practically and sensibly to prepare for the next semester. Maybe to process some of those things that happened in this semester or the year before that you didn't quite understand, didn't quite follow, that frustrated you maybe. But certainly use the summers to pursue topics and areas and exposures that will help you build your career. It doesn't have to be full-time. You're not in full-time studies, so you definitely want to build in some recreational time and some relaxation time and some time with family and friends. But don't ignore the fact that this is a time when you have a little space to read a book about a topic domain, to get a head start on some of that background material that you may have learned as a freshman but suddenly need again as a senior, or maybe even material that you learned in high school and haven't used in the first couple of years or the last couple of years. So use that time to prepare for the upcoming fall courses, and then you'll hit those courses with momentum and with confidence, and you'll do that bit better, and you'll keep up that bit better. So I hope this has been helpful to you. I hope this helps motivate you. Engineering is an amazing discipline. It's a discipline without narrow boundaries. It's a discipline that is always focused on helping people and helping the world, helping every aspect of the lives, the practical lives that we lead, whether it's building a better road or building a better implantable biomedical device. We help people as engineers, and that's an amazingly satisfying feeling to have at the end of a day or a week or a year, that in some small way you've helped society and you've helped move the world forward in a positive way. And as engineers, we get to do that. So take advantage of it, make the most of your studies, ask lots of questions, ask for help when you need it, and I look forward to seeing you throughout your studies here at the University of Utah. Thanks so much.